In the previous section, we talked about what was called mutually exclusive events. Today, we're going to refer as other type of events in probability like the independent events. When do we talk about independent events? For example, when we are flipping two coins, just to give you the best idea. The result of flipping one coin and the result of flipping a second coin, they will not interfere the results of one or the other. That's why we call them independent events. If we have independent events, then independent events are if the occurrence or non-occurrence of the first event has no effect on the second event. So if this idea keeps, then the two events are independent if and only if they fall with this rule. P A intersection B, the probability of A intersection B, will be equal to probability of A multiplied by probability of B. Now, what happens when I have a probability in which what I do to the first event affects the condition of the second event? For example, let's have a bag of marbles. And in these marbles, okay, I take out the first marble and I don't turn it back, return it back into the bag. So the second marble or the second marble that I choose will be altered because of what I did with the first one. That is why two events are dependent if the occurrence of the first event conditions the result of the second event. What does this mean? That the intersection of A and B will be given by the probability of A and the probability of B once A has happened. This is what it means, B bar A. Or the intersection of A and B, the probability of intersections A and B, will be given by the probability of event B multiplied by the probability of event A once B has happened. That means that if the result of B affects A, then I have to consider how that answer is affecting the problem. We're going to see a set of examples in which we're going to be talking about pure independent events, or we can be talking about dependent events on the situation. So let's pay attention to the next examples. Example number 1 talks about rolling two dice. What will happen if we roll two dice and we expect a very specific answer? Problem says two dice are rolled. What is the probability that both come up with a number 5? So what we're talking about in here is that I have two dice like this, and the situation is that they come up with a 5 on top of it, okay? And then I have another die in here, and this die will also give me another 5. So what will happen if the situation is independent? So let's analyze it. The result of this die will not affect the result of the second die. This is what we call independent events. Therefore, what we can do is we can multiply the two results for the probability. So the probability of rolling die number 1 will be, and obtaining a 5 will be 1 out of 6. Why 1 out of 6? Because there is only one 5 out of the 6 faces that we have in here. The probability of event 2, rolling the second die, will be exactly the same. I want a 5 coming up, so there is only one 5 out of the 6 faces that I have in here. So once I have determined independently the two probabilities, then what I do is I find out the probability A intersection B, which in this case will be P of A multiplied by P of B, and the result will be 1, 6, multiplying 1/6, and finally the answer will be 1 out of 36. Or if you want to write it in a decimal form, let's remember that we have as a class rule that we're going to work with 4 decimal places, and the last of the places will be rounded, so we can have this also as an answer. So it's either 1 over 36 or 0.0278. The two of them are considered correct answers. So in this case, we have an independent event happening in here. We have 2 independent events happening in here. We determine the probability of each one of them, and then we multiply the results to obtain what will be the probability that both phases came up equal to 5. Now let's analyze example number 2. Example number 2 refers to a big bag that we have full of balls. So it says a single ball is drawn from a bag containing 5 red, 6 white, and 3 green balls. Find the probability of the following events. The first event is this one. 2 white balls are drawn with the consideration that we return the first ball to the bag before drawing the second ball. That means I take out the ball, then I put it back, and then I take out another ball. Okay, so let's analyze this condition. So the first situation is probability of A picking the first white ball. Okay, so the first white ball will be 6 out of the 14 balls that I have in here. So I have 6 out of 14 balls that we have in here. Now, let's remember we always work with the lowest terms of this fraction. So this becomes 3 out of 7. That will be probability of picking the first ball. Then we return the ball back into the bag and we draw a second ball. Now, since the ball was returned to the bag, then again I have 6 white balls and I have my 14 balls inside the bag. So I have again the same probability. 6 out of 14 written in simplest form will be 3 out of 7. Now in here, since the 2 events were considered independent because we didn't affect the result of the second one, obviously my probability will be A intersection B, and this will be P of A multiplied by P of B, and therefore the result will be 3/7 times 3/7, and finally the expression will be, remember you multiply horizontally, 9 out of 49. So this will be the probability that you pick up 2 white balls, returning the first ball to the bag before drawing the second ball. Part B of this same problem implies that we're going to draw 2 balls from the bag, but in this case, the first ball that we took out first, we are not going to return it back into the bag. So we're going to have a conditioning situation for the second ball. Therefore, what we have in here is that P of A will be drawing the first ball, the first white ball, which will be 6 out of 14, which we already know it from our first example. 6 out of 14, if we write it in simplest form, becomes 3/7. Okay? Now, in here, the second event is conditioned by the first one, because I am not returning the ball into the bag. That is why here we're going to have the probability of B given that A already happened. So in this case, since we didn't return back the ball, now I don't have 6 white balls. I only have 5 of them. And also, I don't have 13 balls in the bag, because since I didn't return the first one, I only have 13 of them. Okay? And there I have my second probability. Now that I have the 2 of them conditioned like this, Then we find the probability A intersection B. The probability A intersection B will be given by P of A multiplied by P of B once A has happened. So according to this, we're going to have 3/7 from the first one multiplied by 5/13 of the second one, and then the final result will be 15 out of 91. With this, we have covered two examples in which we have independent events and we have dependent events, and how the occurrence of the first event condition what happened to the second event. Thank you.